All right, so again, we're looking at the 5B-1 inverse of quadratic and cubic functions. So for the quadratic functions, that's like our x squared functions. And then the cubic is the x cubed. And because we're looking at the inverse function for a quadratic, it's like, how do you get rid of the squared? Well, you take the square root, right? And then how do you get rid of the cubed? You take the cube root of x, okay? So those are going to be like the inverse functions. Is like basically what's the inverse of each, okay? So for today, we're going to be looking at actually, no, I'm going to skip the prior knowledge for today just for sake of time, so you guys can skip those. But the concept for today, we have the inverse of a quadratic function. So the inverse of the quadratic function, which is y equals x squared, is the square root function y equals the square root of x. So to make the inverse of function, because it's the square root functions and we can't have the square root of a negative, like -4, that's going to be imaginary. That's going to give us a 2i, but imaginary numbers are not functions, so we cannot have imaginary numbers. So in order to make the inverse of function, we need to have restrictions that must be placed on the domain and the range in order for us to keep it a function, okay? And then we have the inverse of a cubic function, y equals x cubed, is the cube root function. So the y equals the cube root of x. And then the domain of these functions is the set of all real numbers. So the domain is the set of all real numbers, meaning I can have a cube root of a negative. Question?
We don't have the concept.
Oh, yes. Sorry, I forgot to say that. The notes only have the x squared stuff. I forgot to mention that. Thank you. But just, you can jot down, or you can just kind of just pay attention. It's no big deal, I guess, if it's not on there. So I apologize, but we ended up, I don't know who changed the notes. I don't know how that happened, but we're also doing cubics today. But yes, they are not on your notes. So as I was saying, the inverse of the cubic is the cube root, and there are no restrictions on the cube roots because you can't have a negative of a cube root. So like, for example, the cube root of -8, that's going to be -2 because the cube root means the number multiplied by itself 3 times. So like -2 times -2 times -2 is going to be -8. There are no restrictions to the cubic because you can cube a negative and it'll still be negative. You just can't take square roots of a negative, okay? So only the square root functions will have a restriction, not the cube root functions. So we're going to look at the steps for today for solving. The steps to find the inverse function. We have step 1 is to first change the function notation to y. So like, for example, we're going to go from like f of x and we're going to change it to y, okay? So that's the first thing we want to do. The second thing we want to do is once you have your y and your x, you guys are going to switch them, okay? So we're going to change x to y and y to x. And you're not going to move anything else. The only thing that's changing is the x and the y switch places. So, like for an example, if you have an equation like y equals 2x, that's going to change the y into an x. And the x is going to change to a y. Everything else stays the same, okay? And then step number 3 says to use algebra to solve for the y variable. So you guys are going to be using inverse operations to solve for y. We're going to be looking at PEMDAS like we have been doing in the last few lessons. And so when we use the square root property, only use the principal square root, meaning like the positive value. And then this will make the inverse of function. Step 4 is to rewrite the y variable using inverse notation. So like, for example, we're going to have it in y, so you're going to change it to inverse notation. So that's going to be like the f inverse of x. Or your function might be a g of x, so you're going to change it to y becomes g inverse of x. Or if it's a h of x function, it becomes h inverse of x, d of x becomes d inverse, and so forth. Okay? And then the step number 5 only happens if you have square root functions. Okay? Oh, I forgot to mention too, on your notes, I think these two are kind of flipped. Like what you have on your notes, I think they're backwards. And I slightly changed, I think, the last one. So the last one is if the inverse is a square root function. So this is only an if. If it's a square root function, then the restricted domain, you have to find it, okay? Because again, the square root functions, you can't have negative square roots, so it has to have a restricted domain, okay? All right, so let's look at an example. Can you guys please copy this on your notes? We have f of x equals x minus 4 to the second power plus 3. Oops, I don't know what happened. Okay, so f of x is equal to x minus 4 to the second power plus 3. All right, so if we look back to the steps, step number 1 says to change f of x to y. So I'm going to change this f of x, and I'm going to change it into a y. So that's my step number 1. So y is equal to x minus 4 to the second power plus 3. All I did was change function notation to y. Okay, then step number 2 says to switch the x and the y. So the y becomes an x, and then my x becomes a y, and everything else stays the same. You do not change anything else from the rest of the equation, okay? All right, then step number 3 is to solve. So you're going to use inverse operations. So we're going to look at PEMDAS in reverse. Okay, in reverse. So going from bottom to the top, okay? So first you're going to start with adding and subtracting. So do I have an addition and subtraction symbol? Yes. Well, I see a negative 4 and I have a positive 3, right? However, if you notice, this negative 4 right here is inside of the parentheses. So I'm actually going to do that last because parentheses we do at the very end, okay? So be careful with the adding and subtracting. We're only going to get rid of the plus 3 because that is not inside of the parentheses, okay? So we're going to subtract 3 to each side. Subtract 3, that cancels. And then we're going to be left with x minus 3 equals y minus 4 to the second power. I guess I could zoom out. I don't know. Is that still big enough for you guys? Is it good? Okay. Second period, like, there's that one student on the group A that she, like, can't see. So I feel bad for her. So I always zoom in. But if you guys don't, like, if you can't see, please let me know. And I'll just zoom in for you guys. All right. Do I have a multiplication or division outside of the parenthesis? Nope. Do I have an exponent? Yes. My exponent is a squared. So how do I get rid of a squared? What's the inverse of the squared? Square root it. Okay. So we're going to square root each side. And then the square root is going to cancel out the squared. And then you're going to be left with x minus 3 equals y minus 4. Okay? Oh, yes. Thank you. I dropped my square root. Square root of x minus 3. If I had Jolly Ranchers, you would have got a Jolly Rancher root. I need to stock up on my candy again. So then we have that y minus 4. I still want the y by itself. So notice again, this y minus 4 was inside of the parenthesis. So that's why I'm doing the parenthesis now. I have to get rid of that negative 4. So what should we do? Well, it's negative, so you add 4. Okay? But here, be super careful. That 4 does not go under the negative 3 because the negative 3 is inside the radical. So the plus 4 actually goes outside the radical. Okay? Be careful with that. So this is going to then be the square root of x minus 3 plus 4, and that's going to equal y. Okay, so that was steps 1, 2, and 3. 1 again was just switch function notation to y. Step 2 is switching the x and the y. And then step 3 is to solve for y. So now I have y by itself. So my next step, step number 4, is to change it back to function notation. So I'm going to change the y into an inverse. But I'm going to simultaneously move the y to the front, okay? But instead of putting y, I'm going to change it to function notation. So this is going to be the f inverse of x equals the square root of x minus 3, and that plus 4 goes outside of the radical. And then I have to determine if this is a square root functions or a cube root. And I forgot to talk about that in the beginning. But if you go back to the top, if it has a 2, like the squared function, the inverse of a quadratic function is going to be a square root function. Okay, so the inverse is going to be a square root function. And the ones with the square roots, you need a restricted domain, okay? So the square roots need a restricted domain. And that's like, where's the issue in a square root function? In a square root function, again, you cannot have like the square root of a negative. Like square root of negative 4, because that's going to be imaginary. So you need to restrict it to the positive values. And the positive values are any values that are greater than or equal to 0. Okay? So I need this to be positive. Okay? So this needs to be positive. Because we cannot have a square root of a negative number, okay? So in order to do that, we're going to find whatever's under the square root, and we're going to make it greater than or equal to 0 to be positive, okay? So that's my step number 5, is to get the domain, the restricted domain, and we're going to take whatever's under the square root, so that x minus 3, and I'm going to make it greater than or equal to 0. Because greater than or equal to 0 means positive. And then we need to solve for x. So I have the negative 3 right there next to the x. So to get rid of it, we're going to add 3 to each side. And then we're going to be left with x is greater than or equal to 3. And that is going to be the restricted domain. So I'm going to just add that to like the end of step 4. I'm going to put a semicolon here, and I'm going to say x has to be greater than or equal to 3 in order for this to be a function, okay? And this is going to be your final solution. And so you can go double check it. So if you plug in a 3, 3 minus 3 is going to be 0. So the square root of 0 is 0. So that's good. If you plug in anything bigger, like 4, for example, 4 minus 3, that's going to be 1. The square root of 1 is 1. So that's good. However, if I pick something smaller than 3, like 2, if I plug in 2, that's going to be 2 minus 3, which is negative 1, and I cannot have a square root of a negative, okay? All right, so that was the first example. Yeah, I have to give you a pass. All right, so for number 2, go ahead and copy this on your paper. We have f of x is x plus 6 to the 3rd power minus 10. What's your last name? Today is the 30th. All right, so this one, what do you guys notice this time? What's different between this one and the last one we just did?
It's positive with the 1 inside the parentheses.
It's cubed also, right? So the other one, yes, it had like a plus 4, I think, or plus 3. And then this one has a minus 10, yes. But the main thing is that this one has a cubed instead of a squared. So the cubic functions, the inverse is going to be a cube root function, okay? Sorry. This thing is kind of slow. So the inverse of a cube is going to be the cube root function. Okay? So then I do not need a restricted domain. Okay? So no restricted domain, because I can have a negative inside the root. Okay? All right, so the first 2 steps is always going to be the same. Step 1 is to change the function notation to y. So f of x changes to y equals. Everything else stays the same. So x plus 6 to the 3rd power minus 10. Oops. Then step number 2 is to switch the x and the y. And everything else stays the same. So the y is going to switch to an x. And my x is going to switch to a y. And everything else stays the same. All right, then my step number 3 is going to be to solve for y. Okay, so step number 3, I'm going to solve for y by using PEMDAS in reverse. We're doing inverse operations to solve for y. What do we get rid of first? The 10. So it's negative, so I need to add 10 to each side. So this is going to be x plus 10 equals y plus 6 to the 3rd power. And then I have that cube and the 6 still attached to the y. So what do I get rid of first, the cubed or the 6?
The cube.
The cubed, because the 6 is inside the parentheses, so I can't get rid of it yet. So to get rid of the cube, you would take the cube root, okay? So you need the little 3 in the index of the root, and this is a cube root. Then the cube root cancels out the cube, and we have the cube root of x plus 10, and that's going to equal y plus 6. I still need the y by itself, so now I need to get rid of the 6. So it's positive 6, so we subtract 6 Again, do not put it under the 10 because the 10 is inside the radical, so the negative 6 is going to go on the outside of the radical, okay? So this is going to be the cube root of x plus 10, and then a minus 6 on the outside, and that's going to equal y. So that's my step 3. And then my step 4 is to do what? What do we do next? Once you solve for y, what did we do after? Change it to inverse notation. So move the y to the front, and you're going to change it to inverse. So f inverse with that negative 1 of x equals the cube root of x plus 10 and minus 6 on the outside. Okay, then my step number 5 again was to find the restricted domain, but this is a cube root, and because it's a cube root, I do not need a restricted domain. Okay, so step 5, we're gonna skip. There are no restrictions. On the cube roots. So we do not have to find the restricted domain, okay? You can't, there's no restrictions. So we do not need a restricted domain, so you skip step 5 for the cube roots, okay? All right, let's look now at the next example. Go ahead and copy this one. F of x equals x minus 3 to the second power. Let me close the door. Out outside. Okay. So for this one, that squared tells me what? Is it going to be a square root or cube root? Square root. This one tells me it's going to be square root. So am I going to need a restricted domain? Yes. Okay, good. All right. So step 1 and step 2, again, they're always the same. Step 1 is to switch f of x to y. Everything else stays the same. What do we do next? Tell your group. What's the next step? Tell people in your group. Okay, so step 2, what do we do? Switch the x and the y. It's good. Y becomes x and x becomes y. Everything else stays the same. Okay? Good. Then in step 3 is to solve for y using inverse operations. So I need the y by itself. I need to get rid of the negative 3 and I need to get rid of the squared. But what do we do first? You take the square root of each side. Okay, good. So take the square root of x, and that will cancel the square root and the squared. So this is going to be the square root of x equals y minus 3. Oops. And then to solve for y, what do we do next? Add 3 to both sides. Okay, but again, that 3 does not go under the square root. It's going to go outside. So this is going to be the square root of x, just x, and then the plus 3 goes outside of the square root, and that's going to equal y. All right, tell your group really quick, what do I do next? Y, I solve for y, so then what do I do next? Tell your group really quick. Okay, so what do I do here? Inverse notation. Take the y and you're going to switch it to f inverse. So f inverse of x equals the square root of x plus 3. And then step 5, do I skip it? Step 5 is the restricted domain. Do I need a restricted domain? Yes. This time I do need it because it's the square root. The little 2's in the beginning tells me I need a restricted domain. So again, remember in the very first example we did, the issue is the square root. The square root is what needs to be restricted. So whatever's underneath the square root, so in this case only the x, not the plus 3, because the 3 is not under the radical. I'm only going to take the x and I'm going to make it greater than or equal to 0. And then you would solve for x, but x is already by itself, so then you don't really have to do anything to it, but just realizing that that's the restricted domain. So at the end of step 4, just put like a semicolon and you're saying x has to be greater than or equal to 0. And that would be your solution, the inverse function and the restricted domain. Okay. So for the next one, go ahead and practice this one. I want you guys to do this on the whiteboards. So have conversations with people in your group to solve for this one. Victoria, can you work with Israel and Noel today on the whiteboard? Huh? Yeah. On the whiteboards, not on your papers. So g of x equals x plus 5 to the second power. It wouldn't be a long video. So the solution to this one, you should have switched the x and the y and then square root each side, and then that leaves you with y plus 5, so subtract 5. But that negative 5 does not go underneath the square root, so that's good. And then when you do the restricted domain, remember it's only whatever's under the square root. So only x was under the square root, so you make x greater than or equal to 0, and then just write your final solution. Good. All right, next one. Go ahead and copy this example on your paper. We have f of x is equal to 0.25 times x to the third power. All right, so sometimes you might have decimals, sometimes you might have fractions. So the very first step is to switch still f of x to y. And then here I'm actually going to change that 0.25 to a fraction. Because because it's being multiplied to the x cubed, you're eventually gonna have to like divide by a decimal, which sometimes we don't really ever see decimals in a fraction when you're dividing, so we're gonna change that to a fraction. Okay, so a 0.25, think about money, that's 25 cents. What would it be in a fraction? 1/4. Good, because that's 1/4. So 1/4, all I did was change the decimal to a fraction, and then leave that x cubed there. Okay. Step 2 is now switch the x and the y. Y becomes x, and x becomes y. And then I need to go ahead and solve. So my step 3 is then to solve for y. I have it as a 1/4 and a cubed. So I need to get rid of the 1/4 and I need to get rid of the cubed. But if you think about PEMDAS in reverse, what do I get rid of first? The 1/4 or the cubed? The 1/4 is equivalent to like dividing by 4 or multiplying by 1/4. So this is actually a multiplying and dividing. I need to get rid of that first before I get to the exponent, okay? So how do we get rid of fractions? Do you guys remember? Multiply by the reciprocal, good. You're going to take this and multiply by the reciprocal, which means just take your fraction and flip it. So this is like a 4/1, which is just 4. So 4 divided by 1 is just 4. So that's 4 times x is going to give us 4x equals. Then your fractions are going to cancel. And we're going to be left with y to the 3rd power. Okay, and then how do I get rid of the 3rd? If it was squared, we square root it, but if it's cubed, you cube root it. Good. So you need the little 3 in the index, so the cube root of 3, and the cube root of, the cube root of 4x and the cube root of y cubed. And then the cube root is going to cancel out the cube. So we're going to be left with the cube root of 4x equals y. And then my step 4, what do I do to the y? Change it to inverse. So this is, something I forgot to mention on the previous example. I'll explain it right now, but I'll go back to it. But this, go back and look at the function. This is an f of x. So when you write your inverse notation, it needs to be f inverse. So you guys did the g inverse. Yeah, so it was just like the very first time we did that, and I forgot to mention it earlier, but that's f of x, so you leave it f inverse of x equals cube root of 4x. And then do I need a restricted domain or no? Nope, this is a cube root, so that's your final answer. But this one I'm talking about in the, let me go back to the previous one, because I forgot to mention it. Because again, this is a g of x, then you want to change this to g inverse. But all the previous examples that we had done, they were f of x's. But that last example we did was supposed to be g inverse. All right, go ahead and copy this one now. F of x equals 4/3 to the times x squared. All right, it is a fraction, so I'm going to leave it as a fraction. But step 1, again, is always the same. Step 2 is always the same. Switch this to y. 4/3 x squared. Oops, I changed it to a cube, but that's squared. Step 2, switch the x and the y. Okay. Then step 3 is to solve for y. But again, I have the 4/3 and the squared. So what are we going to get rid of first? The fraction or the squared? You can't get rid of the square until you get rid of the fraction, okay? Because if you remember, PEMDAS in reverse, the exponent is like second to the last thing that you do if there's parentheses. So this you actually multiply by the reciprocal first, so 3/4. Multiply by 3/4. That way your fractions can cancel on the right side. And we're going to be left with 3/4 x equals y squared. And then, what do I do next? square root each side. So square root, square root. Square root cancels out the squared. So we're going to be left with the square root of 3/4 x equals y. Then my step 4 is to do what with the y? Inverse notation. I believe this is also an f of x, so you leave it as f inverse is the square root of 3/4 x. Do I need to do step 5? Do I need a restricted domain? Yes, this is a square root, so I need to find the domain. And how do I find the domain? What do I make greater than or equal to 0? Everything under the square root. So this whole thing is under the square root. So you make that whole thing greater than or equal to 0. So 3/4 x. And then you need to solve for x. That's a 3/4. So how do I get rid of a fraction? Multiply by what? The reciprocal. So 4/3 times 4/3. The fractions cancel. And we're left with x greater than or equal to what? 0. 0 times anything is still 0. So this is going to be x greater than or equal to 0 for my restricted domain. And that's the final answer. Okay. All right. Good. We have about like 6 minutes left, so you should be able to do this one on the whiteboards for me, please. H of x is equal to negative 0.25 times x to the third minus 3. All right, so the solution to this one. Okay. So when you guys get rid of the fraction here, when you multiply by the reciprocal, negative 4/1, you have to distribute that negative 4. So that's why you get negative 4x minus 12. And then take the cube root, and you do not need a restricted domain in this case. So that's your solution, okay? All right, good. We're not going to have homework tonight because we're going to still do more examples on Monday. And then you'll do homework in class on Monday, okay? All right.